So maybe we can do a very short introduction of Kerstin, and I don't think we should introduce all of us here. Basically, Kerstin, you have mostly three groups. On the left, you have Carsten presenting his project. There were a few other co-authors which are not here. You have a bunch of interested students coming to listen and discover the portfolio aspect. And here on the right, you have a troop of the ISOP project from University of Education of Weingarten, which are involved into this ISOP project, which we'll hear a little bit about in your presentation. Do you want to present yourself, Kerstin, shortly?
Yes, of course. Thank you. I am Kerstin, and I'm with the IU for about 12 years now, I think. And right now I'm the project program manager for the AI faculty enablement. And in this role, we created an essay navigator for our students that should help students use generative AI properly for essay writing and not just copy paste it. And I will present you an overview of this today.
Yep, and then we have Christina also here. That's it. Christina, which is in the Mahara team, so one of the leading e-portfolio platforms down in New Zealand. So it's late in the night for her. We had a few more New Zealanders, but they're gone. So you get the floor.
Mm-hmm. So we would maybe start with showing one e-portfolio as example, because we have talked about it in the break. Just need to shine.
Zoom is starting with some patience. The AI is being warmed up. There is some. Yeah, there.
Oh, that's one example, one e-portfolio. I think it's the images are missing because of
export problems.
Yeah, but it's basically mostly text.
Well, it's some structure.
So you get an idea of.
So it's one long document where you can.
It has several pages, so you can also switch here between the pages, and
can you also link the pages to?
Yes, that doesn't work right here because the links go to another Mahara of the Hochschule. This is our Mahara for the project. Yes, and yes, you can link the pages and between the different pages.
The way internal linking can be done is multi-fashion in Mahara. So it happens, unfortunately, that sometimes you get a link which is relative and exported relative. It works wonderfully. Same for picture inclusion. And then sometimes the thing goes, we have introduced some more heuristics to kind of circumvent that, but there wasn't enough so far. There you go.
So, to change.
Oh, you did. Well,
let's see. It's
yeah. Okay.
So.
Oh no, you are sharing the.
Yeah,
no, that's the right one now. Okay.
Okay. So I'm going to talk about the implementation of text analysis in ePortfolio assessment today, and. Okay. So we're using the natural language processing library Spacie to analyze the portfolios, and we have also an own trained model. And as you have seen, the most portfolios are text-based. So we also thought we could look which linguistic key figures we could find to improve the feedback we can give to the students and also to the teachers. And it's also important to note that even though we have an automated analysis, the grading and the reviewing from the teachers is still done manually. So why are we doing all this? We have very long and unique texts, and the manual assessment is very time consuming. So we want to streamline the process, and natural language processing helps, but it's also very time consuming to train a model for every specific use case. So we looked which other solutions exist, especially in the field of computer linguistics, to assess these linguistic key figures. And yes, my impression from computer linguistics is that's a little bit that they only are more concerned with how to assess something and not how to interpret something. And we will see that's a little bit of a challenge. And also the other thing is that we used some little Python libraries to assess these key metrics, which needed to be open source, which has narrowed a little bit the libraries that we could use. This also means that we looked not only to use natural language processing, but also statistical methods and generic models. And we used to conduct a local test with 8 portfolios, in which individual topics were worked on, because we thought there would be the biggest differences, which wasn't the case always. And yes, there's also the question, what insights do we wanted to gain? And we have these 3 levels in our rubric, the content-related criteria, the formal criteria, and the learning process. And as you can see, we have several key figures per criteria. It's also no mistake that the similarity of content is shown 2 times, because one time it's the how independent the students worked on a topic, and the other is how open they were for new topics. So let's start with the key metrics. So one thing is the content depth, which we can recognize with our trained model. And yes, we can identify how much the students have written on a specific topic. And this also means we can find out which topics are occurring parallel. And this also means that we can look at specific topics and assess the linguistic key figures for each topic, which I think is great. But it's also that just counting frequencies is not enough. So one thing that we can measure easily is the lexical density. That means how much information does a text contain, and how much is just filler material. And I have, for examples, we've given them some alias because the number alone was sometimes a bit confusing. And as you can see, John Doe, for example, has written, I think it was the longest e-portfolio in our data set, and he has also one of the highest lexical densities. So it's probably a pretty good portfolio. And we have on the right side, we have 2 of the shortest portfolios. And yes, maybe Peter Pan has written a little bit less than John Doe, but he has a higher lexical density, so he has maybe put more information in its text than Jane Doe. So another indicator we examined is the similarity of content. So our goal was not to detect plagiarism, but to look at how independently the student worked on the topics. And we used word vectors with spaCy to gain this information. And you can see the portfolios listed, and 1 means, or is the score of high similarity. So you see that we have a very high similarity with the seminar slides. And that's not surprising, because in the end, we only looked if they have used the same technical terms or the same words. So it's only on a semantic level, yes. And for assessment of the independency of the students, difficult, and I think it's maybe better for content dev, for finding out the content dev. And we have also one outlier, John Doe in this case, which has a very low similarity, and I can't explain why. So that's also a problem or a challenge. He has put many examples of binary code in his text. And even if I remove this, it has still a low similarity. So these are the challenges that you only find out if you look at practical results. Results, you know. So for the formal criteria, we also assess the text complexity. So this is also a little bit difficult because you want complex text because we are in university, but you also want a text that has a good readability. And it's very easy to assess the text complexity because there are formulas which exist since a long time, since the 80s, which can help to assess the text complexity, which use things like average sentence length or how much syllables the words have. And one problem is that most of these formulas are for English language. And yeah, you can't use them on German language because German words are longer and have more syllables, so you have different results. And yes, we identified 4 formulas that are also work on German. And one is Amstadt on the left-hand side, where the lower the score is, the better, or the more complex is the text. And the others, the Wiener Sachtext-Formel and Lix and Wix, which we will see after that, are the other side, the higher the score, the better. So one thing that you might notice is that with Amstadt, we have on the right side portfolio 7537, which has a very low score of 7. And I thought, okay, that can't be real, so something's wrong. And I looked into the text and I noticed that this portfolio has a very long section of sources with hyperlinks, many hyperlinks. And I removed it and looked if the score changes. And well, it seems that Amstadt is very, yes, yes, with hyperlinks. So if we want to use Amstadt, we need to remove the hyperlinks. Wiener Sachtext-Formel for comparison seems that nothing changed really. And it's also the same with Lix and Wix. Here we have another problem. There are so minimal differences between the portfolios that I think it's also hard to interpret them. So for example, with Wix, 13 would be a high score. And we have now scores between 4 and 6. So it's the question, is a 1 point difference really something, a big difference, or is this a smaller difference? And this is also a challenge that we see with linguistic key figures. Another metric was the lexical diversity. You can use the standard deviation of sentence lengths and word lengths to become a quick insight, but it's not that accurate. And there's the type token ratio which you can use, which is calculated by dividing the numbers of unique words by the number of total words. And the problem with this key figure is that it's the text length influences the score. So there's also the moving average TTR, which calculates the average. So you have not a problem that the text length influences the score. And yes, with the results, you can see that the matter is also very little little differences. So it's once again hard to interpret. Yes. And the last key figure is the coherence. The coherence is how often words or phrases reappear in the next sentences. And well, it gives an insight of the text structure, but we expected generally a lower coherence over the e-portfolios because they have so many topics. And we have found another use that's for identifying lists, because if there's a list and we have a low score, because in lists there are rarely a repetition of the words before. And why is this useful for us? We have made the experience that lists are often copied from the slides directly. And so we can look, for example, in this portfolio at 10%, there was a list. And the idea is that later you can jump right into the portfolio to the text passage, and then you can look if maybe there's a list and how the text is structured. Yes. So overall, I think the assessment itself is not that complicated, but the interpretation is a little bit the challenge of the linguistic key figures. Yes.
Thank you. Okay, direct questions to Pierre? We have just a few minutes for this. No direct questions?
In the similarity of content, so this is just the similarity between the students, because you said something about the similarity to the slide. So maybe it would be good to have the slide as a own person and put it into this, or
it's on the.
It's the last. It's the last slide. And the reason you put only one diagonal is that it's symmetric, probably.
Yes.
Okay. I see. I mean, actually, it's pretty much the same we also had when we were looking at these metrics. That different. I mean, maybe these. I mean, one always look at the whole scale, but maybe these metrics, have you looked at it? What are the real margins of these metrics? Maybe the metrics, it's between 0.4 and 0.5, and there are no other texts in the whole world. Even if you look at Luhmann, and maybe Luhmann has 0.51 or something like this, and then a 0.01 difference could be meaningful. I don't know. So.
Yes, but that's also the point that I meant at the beginning with computer linguistics, that it's more about assessment, and you rarely have sources to discuss what difference is really the difference.
Maybe a word on that one from my side. Andreas briefly sketched that one, but I think it's quite important. What is your objective when assessing the portfolio?
Yeah.
And for us, it's a bit different from the case you are mentioning. In your case, it's formative assessment.
Yeah.
Formative assessment we would like to do if we have the time. Same excuse that you provided, but actually, it's for us it's really on grading here. However, what we don't want to do is to have automatic grading.
Yeah.
Because this is for SEO reasons. Of course, we don't do that.
Yeah.
But we want to have a tool which supports the grading.
Yeah.
And one use case is just to identify what's in this portfolio.
Yeah.
So then I want to have details of a single portfolio and understand where are outliers, where are certain interesting things. So maybe also something what we in our research have as a common ground, as a starting point when trying to apply this kind of technologies. 80% of the cases you see are not interesting, because it's either standard solutions or standard errors. The really interesting things are the 10% unexceptional.
20.
Exceptional. It's 10.
Well, you said
except
80.
the 10 exceptional good,
Yeah.
and the 10 where we really see there's a complete misunderstanding. And as a teacher, I would like to care about these
Yeah.
10 plus 10, 20%.
Yeah.
That's the idea,
Yeah.
to identify them. So in this case, if I take a look at a single portfolio, that's where I want to go to. Is this exceptional? And if it's exceptional, where are these spots? The second one thing is when grading at the very end, it's is it now a 1.3 or a 1.7? How does it compare to another one? That's a totally different story then.
Yeah.
Now I'm looking into what's in certain paragraphs and how does this compare. And as in my understanding, this is also the case in terms of this measures that we have here, how to apply them. In the first case, we might want to have them as an absolute measure. This is high quality or low quality.
Yeah.
Question is whether this really works.
Yeah.
But if I want to compare to two students, then this might be meaningful to say, oh well, it's higher than the other case. So that's why this understanding of use cases, what we would like to do as a teacher, is important. My understanding.
Yeah. So just one quick follow-up. Totally agree with you, but on the content depth slide, did you train it to detect these content areas, or was this like you gave a keyword and then it just could detect what text is like about encoding and what is about encryption?
So about the model,
It's a topic recognizer. We trained the model.
You trained the model. You said a lot of text. Put it. Okay.
Yeah, real portfolios.
Okay. Okay.